Hello there, I'm Thomas. This is an American pilot flying the Boeing 787-900 tonight's flight from Zurich International Airport. We're going to be over from Zurich, Switzerland, Germany. Then coming back to the Zurich International Airport, runway 1449, let's localize the landing. So now I'm in the cockpit for the takeoff preparation. The quality wings Boeing 787-900Z aircraft and Microsoft Flight Simulator X. I'm going to start showing the cockpit instruments, displays, and the functions of the Boeing 787-900 Z aircraft. I'm going to start the primary flight display. That displays the airspeed indicator, the airspeed selected from the autopilot flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the target altitude selected from the autopilot flight director system panel, and the barometric pressure of the outside atmosphere. We have also the altitude indicator with the artificial horizon, the pixel at 8 degrees and the bank angle 8 degrees. The ILS localizer will have the horizontal localizer that receives the radio frequency transmitted from the runway we're going to use for takeoff and for landing. So we have the Zurich International Airport and the runway 14 we're going to use for takeoff and for landing, and the instrument landing system for the runway 14. So we have the onboard antennas of the radio frequency receivers of the ILS localizer, the instrument landing system. You will see the horizontal localizer and the vertical glide slope displayed in the primary flight display when we approach for landing or we take off. So we have also the ILS localizer crossbars, the flight director crossbars for manual guidance of the aircraft, and the autopilot crossbars for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies in the flight mode annunciator with the autopilot and the autothrottle, later on vertical navigation modes. We have also the HSI, the horizontal situation indicator with the magnetic headache and track, and the integrated display of the flight plan. So I'm gonna show you all the instruments of the Boeing 787 cockpit and make an engine start demonstration before making a complete flight from takeoff, climb, cruises, and approach and descent. So you will see in the end part of the video. Stay with me until the end part of the video. So now we have the navigation display. The navigation display that displays the airspeed, that displays the GPS position of the aircraft, the terrain and weather reflections from the weather radar, the terrain map. You can see the airports in the terrain map with the blue letter code for this 4-letter code name. So we have the Lszh for the Zurich International Airport right now that we are located here. You can see also the runway, where it's positioned, its length and orientation. So we have again the magnetic headache and track, the magnetic north pole and the geographic north pole and magnetic variation depending on where we are in the world. We have the navigation aids, the world stations, the ADFs and the Bs, the waypoints which are horizontal and vertical navigation fixes. The aircraft we're gonna have to transverse through as we're gonna be flying some waypoints. So I'm gonna show you how to create the flight plan, and during the flight we're gonna cross through some waypoints. We have also the display, as I told you, the terrain or weather reflections from the weather radar. You can see the terrain with red, green and yellow indication, also the blue for the lakes, the rivers and the sea. You can see other aircraft that fly around us, displayed in the navigation display with the diamond shape. We have the transporter, the DSP and ADC transmitter receiver that transmits our frequency to other aircraft, and the air traffic controller retrieves from other aircraft and displays. It can calculate from the radio frequency the other aircraft position, the altitude difference with our aircraft, whether they climb or descend with respect to our aircraft, also the direction, and calculate also the velocity between our aircraft and the other aircraft. If we have an incoming collision, which is going to give us a warning from the TCA system, traffic collision advisory system. So you can see also we have in the navigation display of these things. We have also the flight plan. I'm gonna create in a few minutes using the flight management computer. So I'll start showing you one by one all the instruments of the cockpit of the Boeing 787 aircraft. So I'm gonna use the flight management computer to input the data of the aircraft for this flight. That includes the takeoff gross weight, that includes the empty weight plus the passengers plus the cargo plus the fuel on board, where the fuel is stored in the left and right wing in the center tank. The flight management computer is going to calculate the center of gravity of the aircraft from takeoff, climb, cruise, and approach and landing. As usual, we're gonna calculate where is stored the fuel, how much we have, 30% in the left and the right wing tank and 10% in the center tank. It's gonna calculate also the loads from the passengers and cargo. Also, as we fly, the aircraft is gonna burn fuel, and this will gonna shift the center of gravity in flight. It's gonna recalculate it automatically every second as we fly. So you're gonna see all these things. So we're gonna have also flight management computer, the fuel on board. So we're gonna have all these things calculate automatically from the flight management computer. The center of gravity and the minimum dynamic chord position of the forward wings, 33% of the Mach is the position with maximum dynamic lift appears in the forward wings. When we fly is the position also where the stall will begin during flight for a given angle of attack and an airspeed that is different depending on the altitude of the aircraft in flight and the conditions, the altitude, whether we have flaps or not, or landing gear extended. So it's gonna have us these things calculated, the flight management computer. Also, we're gonna use the flaps for takeoff, 15 degrees of flaps, and we're gonna use the flight management computer is gonna calculate using the minimum dynamic chord position, the Mach. As I told you, 33% of the minimum dynamic chord in the center of gravity is gonna give us the horizontal stabilizer or horizontal tail trim stabilizer. From takeoff, climb, cruises, and approach and landing, we're gonna trim the horizontal tail of the aircraft or the elevator surface. So we're gonna have this also trim automatically using the auto trim, or we can trim it manually. I will show you the switch we can use over here. In the cockpit, we have 2 switches to trim manually the horizontal tail of the aircraft. You can see here the horizontal tail, and you can trim up and down in most aircraft, or the elevator. You can use also the elevator for climb descent using the side stick. I'm gonna show you the flight controls in a couple of minutes, how to control the flight controls of the aircraft. So you're gonna see all the systems. So we have laminar dynamic chord position, the horizontal trim stabilizer position, on takeoff, climb, cruise, descent, approach, and landing. Also, we're gonna have the runway we're gonna use for takeoff, the runway 14 in the Zurich International Airport. I'm gonna select that using the flight management computer. We'll create a flight plan or a flight path or route. The runway length, the runway slope, the wind direction, the speed, the barometric pressure, the density of the air, and whether the runway size dry or wet. And with the flaps, we're gonna use 15 degrees. The minimum dynamic chord and the horizontal trim stabilizer is gonna give us the takeoff speeds V1, V rotate, and V2. So we're gonna have V2 plus 50 knots for after takeoff. We're gonna have also the seats inserted. The seats are the standard routes with departure waypoints and fixes that include horizontal and vertical navigation fixes from initial departure and climb of the aircraft from the airport. So you're gonna have the horizontal vertical navigation fixes. Then we're gonna have the cruise, the climb to the cruise level, like 25, 36, 37, 28, 29, and 30,000 feet for this aircraft. We're gonna cross through some waypoints again. I'm gonna select using the flight management computer. Then we're gonna have the top of descent. We're gonna descend from the cruise level, like 29 or 30,000 feet, back to 7 or 6,000 feet above the sea level. Closer to the elevation of the airport. We're gonna have the stars, the start of terminal arrival waypoints and fixes for the terminal arrival approach of the aircraft into the airport. Runway, again, the Zurich International Airport, and runway 14 for an Lszh localizer landing. So we're gonna have the horizontal vertical navigation fixes and also the stars, and also we're gonna have the Lszh localizer. As I told you, the horizontal localizer and vertical glide slope for alignment in the runway, magnetic north pole heading of 136 degrees for the runway 14 in the Zurich International Airport in Switzerland. So we're going to have the horizontal localizer the radio frequencies from the antenna of the instrument landing system, from the antenna threshold in the runway are going to be received from the aircraft on board antennas, and going to align with the runway horizontally and vertically using the glide slope. So we're going to have all these things. The Atlas localizer protocol is going to use flaps like 25-30 degrees for approach and landing, and an airspeed like 150, 160 or 170 knots, and also a pitch attitude of 9 degrees for approach and landing in the landing gear extent. So you're gonna see that we're gonna have also a pitch attitude of 9 degrees for takeoff. I forgot to mention that, 9 degrees or less. So I'm gonna show you also the outside view, the aerodynamics of the aircraft. Also here the cockpit one by one, all the instruments. So you can see here we have the primary flight display with the HSI. So you can see here we have the airspeed indicated, the airspeed selected from the autopilot flight director system panel, barometric altitude above the sea level, the target altitude from the autopilot flight director system panel, the flight mode and zero, the autopilot auto throttle, letter vertical navigation modes, the pitch ladder degrees, 2.5, 5, 7.5, 10, 12.5, 15, 17.5, 20 for pitch up or pitch down in flight, and the vertical rate of climb descent of the aircraft. This needle, wide needle, moves up in tens and hundreds and thousands of feet per minute. Or you can set also the FPA, the flight path angle, from the autopilot flight director system panel. I'll show you later. The stiffness of the trigonometric angles, degrees can climb descent. Also we have the bank angle. You can bank the aircraft. You will see also that. So we can change also the heading 360 degrees right now, and the navigation display, the horizontal navigation and the vertical navigation display. I will show you also these things. So we're gonna have the autopilot flight director system panel. You can see the same settings: 200, 360 and 10,000 is 200 knots, 360 degrees heading. So this is the airspeed guidance of the autopilot. Autopilot engage, disengage, heading guidance, vertical rate of climb descent, and the altitude also is gonna be displayed in the navigation in the primary flight display. We have the navigation display here, the terrain map and the airports. You're gonna see later. I'm gonna use a closer range. You have also the left and the right engine, the ACAS, engine indication, crew alert system display. The flight management computer we're gonna use to create a flight plan. Over here I'm gonna insert all the data of the aircraft. The mouse pad. We have the pitch string for the horizontal stabilizer, the alternate pitch string here, the pitch string stabilizer cutoff switches, the fuel control, left and right engine, fuel flow, horizontal trim stabilizer. Also you can trim up like this and down like this, the horizontal tail of the aircraft. So you trim up this way and you trim down this way as you fly. Manually the horizontal tail of the aircraft, the elevator, or you can see elevator trim. So we have also the autopilot disconnect and the head-up display declutter. So I'm gonna show you also these things. The outside view, you can see we have a failure of we use the horizontal stabilizer to balance the aircraft inside as we fly, to relieve the pressure from the yoke. And also we have the auto trim, since this is a fly-by-wire aircraft. So we have a failure of the L2 and R2 hydraulic systems that affects the L2 and R2 horizontal stabilizer. Over here we have the hydraulics pumps. You can see from the left engine and right engine and electric C1 and C2. I'm gonna show you later the overhead panel systems. We're gonna have a failure of the autopilot, auto throttle and auto trim function, and the flight director automatic trim. So which is commanded from the flight control computers. We're gonna have to come down here and open from normal to cut off this guided switch for all Boeing 737, 747, 757, 767, 777, Boeing 777 and 787 from normal to cut off. The auto trim system is gonna start functioning. We're gonna have the alternate pitch trim manual. Over here you can see pitch trim up and pitch trim down, moving this switch, nose up, nose down of the aircraft. So I'm gonna be showing you the flight controls functions with these indications over here of the pit ring, also the outside view. So we'll talk to you about Newton's physics, aeronautical and aerospace engineering and the Bernoulli theory of fluids, a little bit explanations about how some equations we use also for flying the aircraft. So you can see the aircraft, the wings hold the aircraft weight as we fly. We have the thrust from the engines that push the aircraft forward, the vectors from the thrust from the engines, and we have the lateral axis from wingtip to wingtip. The mean aerodynamic chord position, about 23% of the Mach that I told you, is pretty much here where the maximum aerodynamic lift occurs, and also where the stall will begin, the top surface of the wings. As we fly, we have the center of gravity transverses through here approximately. We have the longitudinal axis from nose to tail that affects also the roll action. As we fly, we can roll around it, left and right turns using the ailerons. So the spoilers, we have the lateral axis wingtip to wingtip. We can pitch up and pitch down using the elevator. Over here, as you can see, climb, descent, and also the rudder pedals, the yaw. We can yaw the aircraft around the center of gravity over here, the vertical axis. So you can see also we have the wings. You can see the wings are more flat from the bottom surface, and we have the curvature from the you can see the bottom surface of the wings, and we have the curvature from the flaps and the slat. So this makes the airflow as we fly, as we accelerate for takeoff, and the flying is moving slower using the Bernoulli theory of fluids. We have also the angle of attack of the aircraft from the wings as we fly, so we have a lower airspeed flow below the wings, which creates higher pressure below the wings, which pressurizes the aircraft weight and wings amplitude in the air. You can see also the top surface of the wings is more curved, so we have a higher airflow above the wings using the Bernoulli theory of fluids. So this creates a lower pressure above the wings, which sucks the aircraft weight and wings up into the air. So we have also the deflections from the flight controls. We can move around the rudder, left and right yaw, elevator, pitch up and pitch down. So maybe I'm gonna show you the flight controls in a couple of minutes, seconds maybe. So we're gonna have all these things calculated for this flight and all the systems. So I'm gonna show you how to use these systems, the flight controls also. As you can see, we have the size here, so you can climb and you can descend. You can make turns to the left and to the right as fine. So this is the vertical column of the yoke of the Boeing 787. You make the elevator, the horizontal tail section, the elevator climb and descent, pitch up and pitch down the nose of the aircraft. You can hold neutral, you can make turns left and right using the control wheel. This section is the control wheel. We have the horizontal stabilizer, also the switch here for trimming horizontal tail for extra balance in flight. So you make turns using the aileron spoilers, and also we have the rudder pedals down here. You can see the rudder pedals. We can make left and right turn, yawing turn in flight. For also using the vertical tail of the rudder. For nose wheel steering the ground, we have the tiller interconnected over here, and we have also the toe brakes from the top surface of the. So we have of the rudder pedals, we have the horizontal trim stabilizer, this switch here, the thrust levers here, moving forward and aft. So you see also the outside view for climb and descent, make turns left and right. So maybe I'm gonna show you also this view here is better. of the Boeing 787 Z aircraft. So you will see also this view. So you can see we can climb and descend, make turns. So we climb, descend, make turns to the left, make turns to the right, using, so you can see all the flight controls moving together. All seismic deflection is proportional to the yoke deflection. Also the rudder pedals, both sides, the captain and the first officer, are interconnected in flight, moving together, unless we have a failure, so they're not having the seismic priority button like in the Airbus aircraft. So you can see we have an Airbus seismic pretty much here to command all the functions of the flight controls of the Boeing aircraft. Pretty much the same. No difference. As far as levers also here. You see the engines over here, moving forward enough. So this is the throttle, the thrust levers of the engines. You can see the indication of the engines increase over here. So you can see, I hope you like the Boeing 787, how the cockpit is commanded, all flight controls. Also the outside view over here. You can see we can climb, you can descend, make turns to the right and to the left, ailerons, spoilers also. So you see the vertical, the horizontal tail over here. Using the control column up and down, using the rudder pedals right and left, you move the rudder, and you have also the ailerons over here and the spoilers. We control V, making turns left and right. So you can see all 5 controls. I hope you like them, of the Boeing 787. So I will show you the rest of the cockpit now, all the functions and the instruments. So we have a few things to see over here before making the engine start demonstration. Perhaps I will make the flight plan now. So I have to make the flight plan using the flight management computer. As I told you, I will input all the data of the aircraft for this flight. Then I'm gonna show you the engines and the autopilot flight director system panel, the overhead panel, then make an engine start demonstration. So very quickly, we go here in the control quadrant. As you can see, this side of the cockpit. You can see the pedestal also from the engines. So we have the index here. You can use either indication, other mode like position, performance, takeoff, approach, announced status, navigation data, flight plans, load ATC, track control, load plan, save plan. So we have the identity, Boeing 787-900 aircraft with the engines, GNX 1B54, position, the reference airport. We have the coordinates from the GPS receivers over here. Performance, we can use the takeoff, zero fuel weight, fuel on board. So I'm gonna use this later. I'm gonna create the route now from the departure origin airport. Over here, Lszh, then copy paste. We're gonna use same airport, Lszh, Zurich International Airport in Switzerland. Then we use the runway 14 for approach and landing. So we have departure and arrivals. Over here we select departure. You can select any runway 10, 14, 16, 28, 32, and the seats are arranged with departure. So we're gonna select runway 14, trans Zui to Alpha. Over here you can see the seats are this other instrument departure waypoints and fixes. You will see the star waypoints in the navigation display. We're gonna follow for the initial climb. We have the initial part, then we have the arrival. So we select any runway 16, 28, 34 for the Lszh Zurich International Airport arrivals. ILS 16, we're gonna select again ILS 14. Trans Amiki, we can select any one Gipol, Relax. So we're gonna select Amiki. We're gonna select also the stars, the Negria 1 Alpha. So we have Lszh's arrival, the stars, other terminal arrival waypoints and fixes, and the ILS localizer, the instrument landing system. It's going to be tuned automatically. So we have the waypoints of the flight. The flight plan is almost ready from the first waypoint, second, third, fourth, as we climb, then as we descend. We need only a small fix here. We're going to set reserves 5%, zero fuel weight over here, 322,000 pounds, plus the fuel on board 35,300 pounds. We have the gross weight for takeoff 358,000, the cruising altitude 25,300 feet, and the cost index 100%. Minimum fuel temperature as we fly. Minimum fuel temperature -37 degrees, and the cruising center of gravity 28% center of gravity as we cruise. So we need to recirculate the fuel in flight, because as you can see, minimum fuel temperature is going to be freezing in flight. So we press execute, this green switch over here, the execute, and it's going to give us the purple color over here. The flight plan is active. We have an active flight plan route is activated. So we have the first waypoint, there's at 136 degrees heading to nautical miles 251,900. The Zui would change direction. We're gonna make a left turn. It's gonna be 052, heading 6 nautical miles 302 knots, 6,000 alpha. Then we have Nigria 071 degrees. We change again a little bit direction, 36 nautical miles, 302 knots, flight level 22,100. Mati, we start the descent, 240 knots, 8,400, 12 nautical miles. Amiki, 324 knots, 7,000 alpha. Amiki again, I believe we need one of these. Zui, 180 knots, 7,000 alpha. Z8701, TRA 180 knots, 5,000 alpha. CI 180 knots. We have the approach to the stars, 4,000 alpha. Osnem 170 knots, 4,000, 5 nautical miles, 136 degrees. We're aligned with the runway, 8 nautical miles, 140 knots, 1,450 feet. The altitude we're gonna approach and land. So we have only to set the flaps for takeoff, 15 degrees of flaps, center of gravity automatically. It's going to be calculated for takeoff, 33% of the Mach, 4.25 degrees of the horizontal trim stabilizer, and takeoff speed V1, V-rotate, V2 for this gross weight. So we have departures, arrivals, alternate, VNAV, some other functions, VNAV over here, progress, FMC communications, hold. We can set a waypoint to hold in flight. The legs over here, fix, navigation radio, again initialize reference, takeoff reference. Over here we have the takeoff reference. Hope you see a better view of that. And the legs again. So we're going back to the cockpit. We have a few more minutes left before making the engine start demonstration. So I'm gonna show you the rest of the systems. You can see the flight management computer. Get it from this side. We have the legs active, and everything is displayed here. In the primary flight display, we have the HSI again, the flight plan displayed. And the navigation display, we have the horizontal and the vertical flight plan. Flight path as we're gonna be flying, you're gonna see both what happens horizontally and vertically over here. Also the navigation display, the runway, you can see also the runway we are located right now. Over here is the taxiway, the runway 14 and the runway 16. So if you look around here, you will see from the GPS is correct. So you can see also outside the runways here and the taxiway is the same one as displayed in the GPS receiver. Also the terrain in front of you, some mountains we have. You can see the terrain in the vertical and the horizontal. So in the front of you, you can see these, the yellow and the green, some red maybe, if it's above you. So we're gonna have the terrain avoidance. Over here you can see also how far above the ground we're gonna be flying, and this purple line is the slope we need to follow from the flight plan to climb. So you can see also the distance ring we can have. Over here the terrain, again we have the approach and landing, C14, Osnem, runway 14, PRA. So this is the purple line, the horizontal also depiction. If we look further away, you can see the terrain again with red, green, yellow, some higher elevations, some mountains, and some other airports, Germany, France over here. So you can see over here as we're gonna be flying and cruising, we have to cross through these waypoints. Also we use the plan over here by the display. You can see from takeoff here from this runway, climb, cruise, descent, approach and landing. Some further away airports, again some closer view over here. We can change the range. You will see the waypoints we have selected: Mativ, Negri, Amiki, TRA, C1. It's the same like these ones here, one by one step. In flight, also closer look again, one more time. You will see end up the runway I'm gonna use for takeoff. This direction, the climb over here, Zui, Amiki, Z8, here's the approach and landing. So we look, we use these switches to change the range of the display. If we look closer and closer, you will see the flight plan with a better view, the runway also. And also we can see the aircraft where it's located right now, closer to the runway. You can see the elevation of the terrain, 5,100 maximum and minimum values. Some other functions we can select here, which is also display using a touch screen. So we can use also the center over here, center view of navigation with the compass around, or the standard. So this is the navigation display. You can see also the primary flight display, again flight plan. You can see the airports here further away, so I need to make an explanation of the system. It's a little bit more fast right now. So we're gonna have over here the engine indication, left and right engine, GNX engine installed in our Boeing 787-900 aircraft. One in the left wing, one in the right wing for symmetrical thrust and redundancy. One contains the gearbox of the FATEX. The FATEX are the full authority digital electronic control computers. One is sole per engine gearbox or dual channel redundancy, one channel phase, the other takes over, controls most of the displays of the engine data. You see the upper and lower ACAS, identification throughout the system display like RDN1, which is the low speed starter, low pressure compressor, and turbine of the turbofan, which is the engine, the exhaust gas temperature per engine. The N2, which is the high speed starter, the high pressure compressor, and turbine of the turbofan, which is the engine, the fuel flow range per hour, 1000 kilograms, 1000 pounds, solid pressure, temperature, quantity, and the vibration of the N2 stage of the engine. The FATEX also control fuel metering unit, fuel flow to the engine, engine start, engine shutdown, engine failures, Also the circulation of the fuel in flight. As we're gonna be flying to higher altitudes, we need to recirculate the fuel from the fuel tanks so we won't freeze. Also the lubricants, we recirculate it automatically from the FAREX computers using the recirculation system to duct heat from the engine components and heat up the fuel or the lubricant and the oil. So we have also the FAREX control the pressure inside the engine. We have an under pressure or an over pressure. We can open the outflow valves of the 5th and 9th stage compressor fans, also from the starter of the 5th and 9th stage, which is used also to supply the hydraulic fluid tanks pressurization. So as we're flying, we need to have hydraulic fluid tanks to pressurize the flight controls. So they're pressurized with hydraulic pressure. Over here we have the primary demand pumps and the electric C1, C2. We have the tanks are pressurized using outflow air from the 5th and 9th stage. We have also cabin pressurization here. If we turn from auto to manual, you will see what happens, and oxygen and air conditioning, ventilation, wing and engine radii, so we need pressurizer from the engines. Also we need the APU, the auxiliary power unit. I'm gonna show you later how to start the engine. It's gonna supply with electric power, alternate current. It's a smaller turbine in the tail of the aircraft, and also pressurizer the engine starter. So you'll see here all the engine indications. You can see the outflow valves from the pressurizer we need for cabin pressurization as we climb and descend. Cabin altitude right now 1400. We have maximum 6000 feet altitude of cabin when we're gonna be flying at 40,000 feet. So we're gonna be having a differential pressure 7.8 psi, a rate of climb and descent, and the outflow valves forward and aft. You can see the messages with amber color here: cabin altitude, outflow valve aft and forward. Also the FAREX control as we fly from the sea level all the way up, as we climb higher from the sea level or the elevation of the airport, like 20, 30, 40,000 feet above the sea level, like 9,000, 10,000, 11,000, 12,000 meters above the sea level. As we climb higher, the density of the air, the oxygen level of the air, and the pressure of the air becomes less than half than that of the sea level. Also the temperature of the air becomes freezing, like -30, -40, -50, -60 degrees Celsius. Also the aircraft is going to be flying with an airspeed rate of like 2 or 3 times faster than that of the sea level. So we're going to have a higher intake of airflow from the front fans stage for compression and combustion into the engines, compressors. So we have to refund the engine. So we're gonna have a different fuel mixer request every second as we climb higher. It's gonna be adjusted automatically using the FAREX, the full authority electronic control computer. So it's a good thing to have them installed into your engines, not doing manually like in the trainer aircraft, the propeller or turboprop aircraft. Assigned to this because also as we descend back to the airport and elevation or the sea level, we're gonna have again the fuel mixer request adjusted automatically every second from the FAREX. So I'm gonna show you a few more things here concerning the engines indications. Here you can see, as I told you, we have the N1, which is the low speed starter shaft, low pressure compressor and turbine of the turbofan turbocharged engine, the left and right, 19.8. We have the idle, 899.6, the maximum takeoff, exhaust gas temperature per engine. The N2, which is the high speed starter shaft, the high pressure compressor and turbine of the turbofan turbocharged engine, the left engine and the right engine. The fuel flow per engine per hour, 1000 kilograms, 1000 pounds is 1500 pounds per engine per hour right now, so it's 3000 pounds per hour for idle setting. Oil pressure for 42 psi, oil temperature, oil quantity, and the vibration of the N2 stage of the engine. We have also the gross weight of the aircraft for takeoff, 357,000 pounds for the fuel on board. Fuel temperature right now, you can monitor so we won't freeze the fuel as we fly. So we have a few more things to look at. You can see here we have the landing gear indication, landing gear down right now or retract, alternate gear, if we have a failure of the normal, and lock override for the landing gear again. Auto brake position rejected takeoff. You will see the auto brake or auto brake 1 displayed over here. Parking brake set, doors, and so we're gonna have also over here the speed brakes, secondary flight controls, external retract, flaps position, retract. You can see how many degrees: 1, 5, 10, or extend 10, 15, 18, 20, 25, and 30. Maximum extend. You can see the flaps over here, how many degrees are extended, and also over here outside the flaps and the speed brakes are extended right now. So you use these two handles for the flaps and the speed brakes. We have also this for the thrust levers, as I told you, move forward. And after you will see the indications of the engine exchange. Over here we have a new commanded thrust position. The engine is running. We have also the auto throttle over here. Disconnect switch over here. You press the switch, disconnect the auto throttle like this. Takeoff, go around, thrust reverses for the engine. You will see later when we land. Fuel flow, left and right engine. I told you horizontal trim stabilizer, parking brakes, horizontal trim cutout. So this is the fuel flow to turn off and turn on the engine. Fire extinguishers, left and right engine, pull out and switch, transporter, radio and communication panel, radar trim. So you can see radio and communication panel. You have the navigation radios over here, VHF, SAT, GBWS, WXR. Some other displays here are the FS panel. You can see barometric altitude setting, range of the map. So you set the barometric altitude, minimums, radio altitude, weather radar over here, WXR, traffic and terrain on the display. You can see the barometric altitude setting for this 29.92 inches of mercury and the radio. So we're gonna have also a few more things. Autopilot, flight director system panel. You can see autopilot engage and disengage switch here. Auto throttle left and auto throttle right. So this is the airspeed guidance of the aircraft. So we turn off the auto throttle. Flight director, LNAV and VNAV. Flight director off. Turns off the LNAV and the VNAV. We cannot rearm with the autopilot. So we need the flight director. This switch on. Set the airspeed for takeoff. After takeoff. So this flight director, autopilot engage and disengage. Flight level change, VNAV, flight level change, auto throttle, climb continues. The heading guidance of the aircraft, bank angle limit in flight, has steep banks, and the hold for the heading. So we're gonna use magnetic North Pole heading, 136 degrees of the runway. We're gonna use for takeoff and for landing. So we have the altitude also. Set the altitude here, 10,000 feet, 35,300, and the vertical rate of climb descent zeros. You can descend here, minus. You can see the minus sign or the plus. We can climb the other way. We'll set the FPA, the flight path angle. So now we have the new airspeed and altitude and modes. We have also roll localizer for approach and auto land here. So we have the indications now as displayed. So a few more things to note here. We're gonna start the APU now. The electric left and right IDG, the rate drive generator from left and right engine, the battery. We have also the primary flight control computers here in the auto position, heading reference, the data computer, IRS, so it's pitot static, pitot dynamic, the airspeed and the altitude, the laser gyroscopes, magnetic north or geographic North Pole, heading also IRS localizers, so the air data, pitot, airspeed and pitot altitude, vertical rate of climb descent, GPS position, and the attitude of the aircraft in flight. Air data computer, GPS receivers. Also we have flight control computers over here. FD town power, FD door, passenger oxygen, window heat over here, rammer turbine, hydraulics off, primary demand. You see what happens. Back to the on. And the electric C1, C2. We have on the ice over here. We're gonna turn on the ice on, then auto. We have over here the recorders over here, the cargo and APU fire, electronic engine control for the engine, normal and alternate mode, and the auto start. We're gonna start the engines later using the auto start, left and right engine. We can dump some fuel to lose weight inside. You will need to make an emergency landing, selecting the nozzles and how much fuel to remain. The left and the right wing fuel tanks, center tanks, the fuel booster pumps, the crossfeed valve. We turn it on. You can feed either engine with our pump or either tank. Also, we can balance the fuel between the left and the right. So this is crossfeed. We have also the bleeder from the left and the right engine, the packs for cabin pressurization, we're gonna on the ice, air conditioning, ventilation, oxygen regulation. We use the outflow valves for climate descent and the landing altitude. In auto, we don't need to do anything. We have also the lighting system, wind stabilizers of the aircraft. So this is all the overhead you need to know very quickly. And we go in here. The last thing we need to see over here before going for the flight, the digital format of all the systems. I just show you. So you can see here we have hydraulics, APU, oxygen, liquid cooling. You can see all the indications, quantities. Electrics, I told you, left and right IZ, great right generator, 120, 200 volts, 400 Hz frequency. The APU also 120,000 kilovolts from its left and right engine. The load set, the battery voltage, and the APU battery voltage and average. So this is electric, hydraulics, where the hydraulic fluid goes, left and right engine, demand primary 5000 and 5000 and 5000 psi. The electric also, set off valves, and the fuel left and right, wing fuel tank, center tank, how much fuel you have, 11,000 and 11,000, left and right wing, balance and center tank, total 34,300 pounds. Low and high pressure fuel valves, left and right engine open and feed from the center tank or the wing tanks using the fuel booster pumps forward and aft. The APU is fed from the left wing using the DC motor. We have the crossfeed valve. If we turn it on, we can feed either engine with either pump or either tank, or balance the fuel between the left and right engine. We have here also the minimum fuel temperature, as you can see, minus 37 degrees, and the temperature of the fuel minus 3 degrees right now. It's gonna be freeze in flight, so we recirculate the fuel automatically into the engines to heat it up alongside with the lubricant and the oils. Pressurized air, the pump left and right engine, the oxygen, the doors are closed, the cabin can be pressurized, the gear, pressure of the tires, temperature of the brakes, the nozzle, also flight controls over here. Last thing to see, maybe flight controls are working the way it should be. Over here, climb descent, mid turns in flight. So you see the yoke and the rudder pedals, the position, how many degrees you want to make turns. Also the elevator and the rudder. Horizontal trim stabilizer, FS display, maintenance, digital maintenance and circuit breakers, also digital over here. So we have the checklist. Last thing, normal menu, what to do before before taxi, takeoff, after takeoff, descent, approach, landing. So this is the checklist. Also communications. So we go back in the navigation display. We need to turn off both engines and restart them very quickly. So we turn off over here the fuel control, as you can see. So you'll see the engines indication, fuel control to the off position. We're gonna have some warnings coming up. I'm having the engines gonna start like this. So we need to restart the engines. So we go over here in the overhead panel very quickly. Both auto start left and right over here to the start position. You're gonna see all amber lights when we use the auto start. So we're gonna be having a couple of minutes for this process and going for takeoff very quickly. So we have pressurizer above 20%. We have no fuel flow yet, so you can hear the roaring of the pressurizer into the engines. We need to start the fuel flow now. Over here, fuel control, both of them. So we have the auto start kicking in for both engines. So you can see auto start left and right engine. You're gonna see the hydraulics also coming back to life over here from the flight controls. So a couple more seconds, you can see the yellow indications are going off, the systems are alive, and we're gonna have an auto start after 60% pressure. We're gonna have the running engines. So both engines are running right now. So we set flaps for takeoff over here, parking brakes off, and we're going for takeoff. Advance the thrust levers, use the tiller for steering, for nozzle steering. So we make a turn and going to the runway. We'll take the air traffic control for this runway. It's empty right now. Anyway, we have no traffic in here. So you can see we taxi like this. So we make another turn here, using again the tiller. So we use this tiller for nozzle steering and the rudder pedals whenever needed. So we advance the thrust levers, take off, go around, thrust. And we're going for takeoff. Full takeoff power. Align with the rudder pedals. So we have 120, 130 V1. We rotate slightly like this. So pitch up slightly. We have the positive rate of climb. So landing gear up. Over here, landing gear retract. Keep climbing. So we depart the runway, as you can see, the airport. So you can see here, we can see we are 2,400 feet above the ground, but 4,000 feet above the sea. The airspeed 168 knots, the stall speed yellow and red. The rate of climb 4,000 feet per minute. The pitch altitude almost 20 degrees. The flight plan we're gonna be following here, as you can see. The overhead panel, everything looks normal. We have also some indications here, the flight plan. You can see how far above the terrain we are here, almost 4,000 feet. You can see the aircraft symbol and the terrain below you as you're going to be climbing, and also the terrain around you. You can look further, see with the yellow and red and greens some mountains, almost the same elevation with us. The engines also. So everything looks normal. We're going now for the turn. Look outside. Nice view of the Boeing 787 as we depart over here the Switzerland, the runways, the airport, and the Switzerland view. Beautiful Swiss Alps here. So we need to start the turn over here. So I'm gonna begin like this. And we need 18 more minutes for this flight video to end. So we keep climbing. So this is the video of the cockpit after takeoff here. Also some outside view over here, very nice. You can see we have a nice galactic view overhead, and the Boeing 787 as we depart the Switzerland, the Zurich, the Swiss Alps. We're gonna be flying over Germany, my homeland here, Bayern Munich, and France, also the Italy, very close to us. So hope you like this view as we keep climbing. So we are 14,000 feet, need to climb a little bit higher, and it's a little bit we cannot change the view here in the map, look more clear the flight plan as it's gonna be flying. And we need 17 more minutes to finish the flight approximately. You can see also this view, this side, the autopilot here. "17,000 feet. I'm gonna start making some turn now over here. A nicer view. Also the lake, we are getting closer. Maybe climb a little bit higher, retract some flaps, maybe we're gonna accelerate to higher airspeed. As we climb. So 20,000. Need to keep climbing. And we have 15 more minutes aligned with the flight plan here, this purple line, as you can see. And we have the next waypoint right now. To intercept the Negra is 24.7 nautical miles, as you can see over here. 24.1, 33.9 is gonna be now. So we keep climbing. The airspeed, the stall speed here, indications are correct, and now we follow the flight plan, the LNAV navigation. So we keep climbing, and we need 14 more minutes for this flight. So we're gonna be flying very close over here, the France, the Germany, these lakes, and we're gonna have a nice view of the galaxy over here. the Boeing 787. We're flying 22,000 feet right now, as you can see. Keep climbing, and we need 13 more minutes to go back to the airport. You can see the waypoint. We have to cross through here, the Nigra, and here we are 18.5 nautical miles, just like in the flight plan. Maybe we need to start now going back to the airport. We have 13 more minutes to go to the airport. So we're gonna make a nice turn here, overflying this lake. And we have the chemtrails already, the frozen vapors. 24,000 feet over here. Hope you like it. Frozen vapors, and overflying Bayern Munich, Germany, and the lakes here. So I keep turning like this, and we need a little bit right rudder now. As we turn, almost reach the cruise altitude here. A little bit right rudder for the turn to make it a little bit more coordinated. And to level off here, we're almost to the way back, as you can see. Leveling off here, you can see how nicely we level off manually. 5,500 feet, overflying the lake and going back home. We need a little bit more turn, follow the flight plan, and we have 11 more minutes left for the flight. So retract the flaps here. I'm gonna be accelerating. Higher airspeed, actually. So now we hold manually, as you can see. We can use the autopilot in a couple of minutes. So we accelerate to higher airspeed. So you can see again, we have 9 more minutes left for the flight to go back home. We're overflying the lake, the France, the stars in here, the galaxy. So we can use the autopilot if we need to engage it in any way, like autopilot connect. Just for a display how you use the autopilot connected with the Boeing 787. You will see a nice alignment now. So this will connect us with the line. We need to have a heading over here in the line, so we have a nicer view over here of the flight, connected with the autopilot now, engaged. So we're gonna start the descent now, back to the airport. Idle thrust, select also lower altitude. We keep flying manually. Idle thrust, speed brakes extend. So we have a few more of the chemtrails we leave behind. So we need to descend now over here. And we have 7 more minutes left for this flight. Let's see the waypoints we have to follow here for approach and landing. We need to descend over here. And we start the turn now over here. So we descend manually for approach and landing, and have more than 5 minutes for approach. We need to descend a little bit lower. He's a little bit left rudder now as we descend. Maybe launcher extend. It's gonna slow us down a little bit. This is how we take the turn here, as you can see, for alignment with the runway heading. Also some flaps here. So we increase the rate of descent a little bit. And we have to align the runway heading now. Over here we have the runway. Add a little bit more thrust. So we are almost very close to approach and landing stage like this. So you'll see also the approach and landing phase, also the view. We need to increase the airspeed a little bit, get a little bit faster over there in the runway. So we have 3 more minutes left. You can see we have also the Lszh localizer, all the information. We need the airspeed, the needle. We need to make a little bit turn to the right, rather pedals to the right for alignment. And we need about a couple more minutes for approach and landing. Also flaps maybe full as we are approaching. We have some side wind. We need to use all flight controls to combat the side wind and the gust to make maneuvers for approach and landing. So you can see the runway, it's over here. We need a little bit more idle thrust as we are approaching. Also a little bit right rudder now to align with the center line of the runway. And a little bit yokes control, rudder pedals, also control wheel aileron spoilers, elevator as we are approaching the runway for landing. And you can see a little bit more idle thrust right now. Again align with the rudder pedals, right rudder now, left rudder now. A little bit more thrust. And we have a lot of side wind, which blows the aircraft in the side, away from the runway center line. So we need also to increase the rate of descent now. Also we have the flare now. Flare is the aircraft. You can see the flare. So flare touchdown, very beautiful touchdown, idle thrust, parking brakes and thrust reverse, full thrust reverse over here. And we made a very beautiful landing with a lot of side wind. We need to use rudder again, right rudder to maintain the center line. Now left rudder. Okay, so we're slowing down. So you can see here we have the nose wheel of the aircraft is perfectly safe. There is no breakage. Also the landing gear behind all the wheels perfectly safe. Every part of the aircraft. So the aircraft is standing up the way it should be in the runway with its nose wheel here, as you can see. So now we go over here, disarm the thrust reverse. Disarm the thrust reverser like this.